So I'm Jeffrey Palermo, and I think it was probably 7 years ago where I was, maybe six or 7 years ago, I was at this user group presenting. I think Jason Alexander was part of the running the group, if anybody remembers Jason Alexander. But anyway, Jeffrey Palermo, I live just to the west of Austin, and Scott Wilson is also here. He is an architect at ClearMeasure, and I'll talk a little bit about the company, but mostly about Blazor, because that's what we're here to talk about. And I have a lot of content. I could probably talk for 2.5 hours straight without taking any questions, but I'm just going to kind of pick and choose. Show of hands, who here has at least compiled and run the template Blazor application inside Visual Studio? Okay. All right, so some of the what I consider the basics, I'm just going to breeze right past because you've already played with some of the bits and all that. Okay, so a little bit about me. Hobbies is motorcycles. Currently doing the off-road racing thing. My boy and 2 daughters have all done races. Just a couple weeks ago, I celebrated 20th wedding anniversary, and you can see down with the longhorn cow. We live just enough outside of Austin to where we can graze some cows. So that's kind of fun. I'm also the host of the Azure DevOps podcast. Has anybody listened to that podcast before? You can go to any of the podcast directories and just search for Azure or DevOps, and it tends to be in the first 5 of whatever you search for there. And also a new video podcast that is now 18 episodes in. So kind of brand new, 18 weeks in, Programming with Palermo. And whereas the audio podcast is all about bringing in guests and interviewing them, this one is just me teaching. You can search for that in any of the podcast directories as well. And we got the print books. If you don't get one of the print books, just send me an email and I can get you a digital copy. Okay? So just send me an email. My email will be up at the end, but it's Jeffrey, Jeffrey, at clear-measure.com. All right. Don't have it here. I can talk about it at the end, but before I just go into this, if you're wondering, what the heck is ClearMeasure? ClearMeasure is a software architecture company that serves companies with in-house .NET teams to help them move faster, increase their quality, and to increase their production system stability. And so we serve .NET teams who want to be awesome, and we help fill in those gaps, push them in the right direction, anything from just even advisement all the way through jump starting something. And of course, over the last number of years, tons of people have been doing new cloud stuff, tons of people have been doing automated deployments and other things for the first time, distributed systems, just whatever it happens to be where they need a little bit of jump start so that they can take it further. All right, so some of the architecture patterns that I'm going to talk about come from a particular auction system that I did a lot of heavy work into for the livestock industry, and you see a screenshot there. And what's interesting about this is that it actually has a different type of intensity to it. So let me set the stage. Whether it's a livestock auction or a car auction, it's fast moving. And if there's people watching it online, and this is a picture of a listing and showing the prices that each one is going through, but also has a digital signage component to it. So anywhere, on the fairgrounds, in the building, or around the world, here's some digital signage that runs on a Fire Stick, Roku stick, any of those smart TVs, and it just kind of listens for events and listens to update. So when the price changes, anybody who's looking at it, any of the screens that shows the price, needs to have it instantaneous, okay? And it moves fast. It's not something where you sit there and you can rely on the user refreshing. Actually, you don't want the user refreshing. And so it's more of a push of information. And you can have the live auctioneer calling out bids. Different auction modes are silent auctions, where you know right about the time that an item is about to expire its time, people are putting in, thinking they're going to swipe with the old eBay style, last minute, And so the bids are coming in fast and furious. And so there's just an interesting level of intensity in this type of domain. And aside from Blazor, the Azure SignalR service is a very important architectural piece because it does the real-time messaging out to any number of clients that happen to be connected at a point in time. Okay, so we're going to go through a few categories with Blazor. We're going to talk about just high level some of the things that I think are interesting architecturally about Blazor and the different styles. Some things you want to think about from a memory management perspective, how Blazor tends to manage memory and what it tends to look like. We'll talk about applying hub and spoke patterns to Blazor applications. We'll talk about eventing, both eventing underneath the user interface and eventing across the user interface. We'll talk about the different levels of testing as it applies to Blazor, and then we'll talk about monitoring a Blazor application. And I've got 2 GitHub repositories to share with some examples. So any of the code in either of the 2 Visual Studio solutions, it's all on GitHub. You can get to everything. And actually, I've talked about both of them pretty extensively on the Programming with Palermo episodes. So you can go and watch those and dig in deeper. Okay. As with any .NET application, first and foremost, I just want to stress the importance of setting up Blazor applications in a really, really good and complete development environment. And I would say 5 years ago, I would say DevOps environment, because that was the buzzword. But DevOps is kind of old. I mean, from my perspective, it's been so much, it's just about having a good environment for yourself. And there's good stuff from Agile, there's good stuff from extreme programming, there's good stuff from DevOps, but you want a complete development environment. The good news is Blazor is just another project type, just another .NET, ASP.NET project type. And so it works with, if you already have an automated build style, it's going to work with that. If you already have an integration build server, it's going to work with that. And if anyone is interested, this is the top third of a DevOps architecture poster that we use, and it's annotated for the places where you have to do a little something extra because it's a Blazor application. If anybody wants that high resolution PDF, it's meant to be printed on a 2-foot by 3-foot poster in a print shop. Just send me an email. We can get you the high resolution. But I'm not going to dwell on that. I just want to stress the importance that you don't want to say, oh, Blazor somehow means that I don't have to do testing, that I don't want to do automated builds, it is just another .NET project type. Okay, let's talk about version control. In a Git repository, you want your Git repository to have one logical application from an architecture perspective. All right, so if your Blazor application is going to go inside a Visual Studio solution, that's probably your logical application. You don't want to have a Blazor application mixed in with 10 other applications. And I'm talking about an application from an architecture perspective. It's perfectly fine to have a Visual Studio solution with a Blazor app, some console tool, some type of service worker that's processing off of a queue, and a database. That's all normal because it's one logical application. You deploy it all together. But I just wanted to stress that because in the era of talking about microservices, we're decomposing larger and larger systems into smaller pieces and putting the smaller pieces in their own isolated Git repository. But you want to make sure that whatever is in that Git repository builds together, tests together, deploys together. Okay, that's an important piece. And it's perfectly legitimate to add a Blazor project to an existing Visual Studio solution as long as architecturally you're building it together, you're testing it together, you're deploying it together. Architecturally, it is one versioned application. It has one version number, even though it may have multiple deployable pieces. Okay, I'm going to skip over the architectural differences between a Blazor server-side and Blazor WebAssembly because all of you have done it. And if you haven't really understood it deeply, Blazor server does use the server, CPU, and memory for everything. WebAssembly uses the browser, CPU, and memory for everything. Okay, well, that's basically the high points. There's a lot of details that go into that. Now, on on the server side, if you've never pressed F12 and looked at the messages going past, I encourage you to do that because you need to know how chatty Blazor server side is. Now those messages, you can't see it on the screen, but those messages are super small. Look at it, 540 bytes, 90 bytes. That's a tiny message. These are binary messages. You can't really look at them. They might have something that tips you off like, oh, on render completed, ... where you can see, oh, that's probably related to that. But it's not, the browsers don't have binary viewers for these messages yet. But go and look at it and you can see how chatty it is. And then you'll understand why Blazor server-side applications totally fall down in a high latency scenario. If you have high latency on a network, you do not want to go after Blazor server-side because of the number of round trips to the server. Now, if you have a low latency environment, you don't even notice. It's great. It's highly productive. All your code's in one place, and you can just jam out features like nobody's business. You also don't want to go after Blazor server-side if you have lots and lots of users that are going to have your application open at any given time. Because even if they're doing nothing, the server is going to hold a certain amount of memory just because they have a user session. And then your server memory that you have to have just for people to sit there doing nothing, it grows and grows and grows. So if you have a small number of users, you have low latency, and this is perfect for in-house applications where you actually know the people in your company who are going to be using an application, has a low scale, low number of users connected. Server side, super, super productive. It's actually really awesome, okay? Blazor WebAssembly, when you have a large number of users, when you need to scale it out more. Why? Because we're using the user's CPU, the user's memory, the user's browser. So those are the high points. Okay.
What's the number of users you consider to be high? Where's the threshold?
Okay, so I have seen on a Azure on the P2 V1, which I think has the, how much of RAM does it have? Does the P2 have? I think it has 1.5 gigs of RAM, where the P3 has 3.5 maybe. But the V1 P2, it's like the first production, the first big app service, connecting 50, kind of just with user sessions, it kind of started cleaning up memory and not being happy, just with server side. Now, if you're just running the template, which you don't have much going on, there's not much memory, your ceiling is probably a lot higher than that. But this is an application that I didn't consider, being that much of a memory user, but every session is being stored in server-side memory. Okay, so Azure App Service is your friend. Azure Container Apps is upcoming, but I'll just tell you right now, it's still cutting edge. And if you don't want to bleed, if you just want to use mature tooling and you want to have the documentation be right, and you want to have all the samples that you download just work first time, go ahead and just watch and see with app services. Just kind of keep an eye on it. It's not there yet, okay? A lot of promise, but it's just not there yet. And I want to be honest. So if you want to just blow and go and be super productive, app service, okay? App service is going to work hands down, no drama. It's really stable with Blazor applications, with tons of applications, but specifically, you can count on it with Blazor. Here are some settings you want to make sure of. Platform, 64-bit. A lot of applications and developers start out with the free version, and then they kind of scale up when they're ready to go. Well, the free version doesn't support 64-bit. So if you start with the free version, now you've created something, it's 32-bit. Unless you go in and intentionally change the setting, it's going to stay at 32-bit. So watch out for that. Okay. Down below the radio buttons, WebSockets. The free version of App Service doesn't support WebSockets. So Azure SignalR is going to be self-hosted by default in Blazor server-side, and it's going to default to long polling, which is going to just eat up a portion of your CPU. So you want to make sure when you get off the free version, you make sure to enable WebSockets. Also, if you're using server-side, get off of self-hosted SignalR. Move over to Azure SignalR service. Even though Azure SignalR Service says that above 1 million messages in a given month, or I don't even know what their time frame is, you're supposed to upgrade and pay more. I've never seen a situation where I actually had to upgrade and scale up SignalR service, and it went way more than 1 million messages, and it never slowed down, and it's never been more than a rounding error in the Azure bill. Okay, so there's no reason not to use the Azure SignalR service. And AR Affinity. With SignalR, with a server side, as soon as you go to 2 instances of your app service, you're going to feel it if your AR Affinity is still set to false from being on the free tier, because that's your sticky sessions. All right? Server A has the memory for a user session, so every bit of their traffic needs to go to server A. If you don't have the sticky sessions on and it goes to server B, well, now they're starting a new session. It boots them to the starting page of your app, and there's no memory. Okay? Now, for WebAssembly, AR Affinity doesn't matter because the only thing happening on the server is web services. And so you actually don't want sticky sessions for web services, right? And you'll probably still end up using SignalR even for WebAssembly because it is so useful to be able to push things to all the connected clients. You just won't be using the built-in SignalR for Blazor server-side. Okay, here is just one sample solution structure. This is actually the solution structure for the car auction application. And you can see it doesn't really look a whole lot different from other .NET applications. This does happen to use the onion architecture dependency model, where the core project has all of the entities and the business logic, and everything else kind of ends up referencing up to it, but it doesn't reference anything else. So none of the business logic, none of the entities reference data access. Those dependencies are flipped, and data access references it through interfaces and dependency injection. So it's not going to look a whole lot different from other .NET applications that you're using. One thing that turns out to be really, really useful with Blazor applications is to actually have multiple. Okay? So you see UI and UI.admin. Let me tell you what that is. UI is the main user interface. All right? And by the way, some of the onion architecture thinking is thinking about your interfaces. So you have core, and then you have interfaces. What are we interfacing with? We're interfacing with the database. So we have data access. We have a project for the interface over to the database. And then there's an interface over to the user. That's why it's called UI. It's just that way of thinking. It's like, okay, what external things do I interface with? But you have UI and UI.admin. It's because there's a few screens where only someone with special permission needs to go there. Now, I could just have one application, and I could figure out how to restrict those 1 or 2 screens, but then I have to put in some role-based permissions and some restrictions. But it turns out, if that's your only issue, that you have just a few screens that maybe a super admin is supposed to get to and nobody else, it's so easy to say, you know what? It's actually easier to not implement any of that role-based security and permissions and just have another application where I take the security, and instead of it being permissions, I just rely on authentication. And hey, guess what? Only this user can even log in, period, to this one application. This one application over here is the admin application. It has those 1 or 2 screens, and nobody else can even get to it, see it, log into it. So that's something to consider. It kind of removes that concept of role-based permissions that you don't. If you don't need to implement it, why? You know. Okay, here's another different application, and I'll actually show you the code a little bit later on of this one. This one is in GitHub. It's a sample application, and you can see the structure, very similar, but I'm going to come back to why we have UI.client, UI.server, and UI.api. That'll be really interesting. But notice, we still have a core project. We want the core project to not have pretty much any references except for simple libraries inside the .NET SDK itself, and we want most of our code to be in core, and then everything else just to reference it, use dependency injection to wire things up. Okay, let's talk about memory management a little bit. Okay, so .NET Core basically made inversion of control, IOC, normal for every .NET application. Before .NET Core came out, you basically used the NuGet libraries and structure map, autofac, castle, any number of IOC container libraries, and therefore only a subset of developers were using the concept. Well, Microsoft bakes it right in, and now every .NET developer is like, oh, okay, I need to learn this if you hadn't already before. And so it's front and center, and everything uses it. There are 3 scopings: singleton, scoped, and transient. They do something totally different in Blazor and depending on the Blazor style. Let's go through them real quick. All right, singleton. With Blazor server-side, singleton is if you ask for a certain type, you're going to get 1 instance of the object per process on the computer, on the server, okay? So Blazor server-side, you have 1 process that's running on the server, no matter how many clients are connected to it. So if you ask for a particular object, you're going to get 1 instance, and every user is going to share that 1 instance, except if you grow your web farm and you have two servers in your web farm. Well, now guess what? You got another one. So you're going to have 2 overall. And if you have 10 servers, you're going to have 10. On WebAssembly, where is the Blazor process? The Blazor process is in the user's browser. So what does this mean? You're not going to get 1 for each server. You get 1 instance of the object for every user session, because now the process is inside the browser, okay? All right, so that's how it changes it. Let's go down to the next one, scoped. All right, scoped used to be called hybrid, and then Microsoft kind of renamed it scoped. But it really was meant for web requests, where for the life of a web request, you'll get the same instance. So if some code at the beginning of the web request asks for something, and then some code a few milliseconds later in the same web request asks for it again, you would get the same one. Okay, that's the purpose of it. So Blazor server-side, the life of the web request. Anybody know how long the life of a web request can be in Blazor server-side? It's unbounded. All right, let's go through this. So browser hits the server. Hey, give me the application. Oh, it's a Blazor server-side application. The Blazor, what's it called? Blazor framework.js. I even forgot the name of the JS file that comes back. All right. None of our C# code actually goes to the browser. It's just a lot of JavaScript that goes to the browser, which turns right back around and opens up a WebSocket connection back to the server and sits there, okay, and never closes. So that web request opens and sits there, and then all the messages go back and forth, no matter how many pages. So the life of a web request is basically the life of the browser window, because until they close that browser window, the web request doesn't end. So if you have something set as scoped, well, the same object could last an indeterminate amount of time. All right, let's switch to Blazor WebAssembly. With Blazor WebAssembly, the life of a web request is kind of irrelevant, because you're on, again, the process is on the browser at the user's computer, and so the life of a web request is it's kind of the same. It ends up behaving the same as singleton for them. So it's going to be the same as a user's session, okay? Which that's particularly fine if you want it to be that way. Now transient is the one that it operates the way you expect it to. No matter what, no matter when, if you ask for another instance, you're going to get another instance. Okay. There is an abandoned session timer built in with Blazor server-side. And by default, it's 3 minutes. You can change it, but it's 3 minutes. And it's for a situation where I'm on a mobile phone. Mobile phones get it the most. I mean, it can happen with any computer, but I'm browsing the application and then hit the side button, stick it in my pocket. Well, the phone is hibernating me. It's totally cutting it off. From a server's perspective, hey, this client is gone, right? Because of hibernating. Now, if I open it back up within 3 minutes, whoop, oh, let me reconnect. Oh, you already have a session. Okay, let me just reconnect you, and it's all great. All right, so that's how it works. And if you're on Wi-Fi and it's kind of spotty, that's how within 3 minutes. Now, after 3 minutes, it marks all of the memory in your session as garbage collectible. Then the .NET garbage collection kind of does this thing. You can change it. So when we get to the the telemetry session, I'll talk about how it's important to know how many open sessions you have if you're doing Blazor server-side, and how to put some of those metrics on your App Insights dashboard. Okay, with the version before .NET 5 came out, the DB Context Factory for Entity Framework was not in the framework, if my memory serves me correctly about when they put that in. But if you have some code that says services.add DB context, whatever your DB context class is, and that was working fine at ASP.NET MVC and other applications, and then you use Blazor server side, under the covers, that registers your DB context as scoped, okay? Not what you want for Blazor server side. And so there's an article that the Blazor team came out with and then subsequently fixed it with the DB Context Factory so that for Blazor server side applications, there could be a DB Context Factory that was scoped, but then you still get mostly transient DB context, but you get control if you in your code decide that you want to use the same DB context for two operations, if that makes sense. All right, so watch out for that. Okay, if you're just doing the old style add DB context and not thinking about it, do a little profiling on your DB context in your queries just to make sure it's doing what you wanted it to do. Okay, let's go to hub and spoke patterns. I love and recommend using hub and spoke patterns for every single application, okay? Every single application. I am a fan of CQS, command query, separation, segregation, name your flavor, just, got to keep them separated, all right? Anybody here used CQS before? Commands, queries, events? Okay, so this is a big idea. Oh, and by the way, just because it's cool, see the diagram on the right? That diagram is auto-generated from code that's put into a Git repository. It's called plant UML, and it's a syntax for architecture diagrams that are Git diffable because they're just text, and then you just do a little hotkey in VS Code, and it just generates the diagram based on the text. So if you've never checked out plant UML, then check that out because a lot faster than Visio, a lot faster. And you just copy and paste as templates just to make new diagrams and whatnot. Okay, so at the top you have, just conceptually, you have your Blazor powered screens, and then they ask of things and they send commands into the application through one API. When I say API, I'm not talking about web service. Through one code path, all right? And that is the bus, all right? Now, there's different styles of the generic bus. There are brokers, which the old BizTalk tool is a broker. If anybody's ever heard of BizTalk, where there's intelligence. A broker knows about every destination intimately, okay? And so it has dependency on every spoke when you think about the hub and the spoke. I don't like that style. I like the style where all of the spokes, or we'll call them handlers, have a dependency on the bus. It's the other direction. So the bus, it doesn't actually know if there's a class, a handler, that can actually handle a query or not. It basically, at application startup, all the handlers tell the bus, hey, I'm here, and just stick them into a collection. And the bus, when it receives a command or a query, literally just loops through the collection, figuratively, loops through and says, hey, do you want this object? Do you want it? Do you want it? Do you want it? And whichever class says, yes, I want it, okay, here you go. All right? Literally, that's the pattern. So the UI, the user interface, doesn't have to have all these different classes. And if you have 100 screens in your Blazor application, and then 100 pathways of where in the application the right method of the right class needs to be called, that's actually really hard to maintain. And really hard to refactor, and really hard to add new behaviors. But if every screen in the user interface has one abstraction to get into the next layer of the application, then it doesn't matter how many screens are added into the future, how many new capabilities, you have that one. And actually, the .NET framework, if you look at all the pieces of .NET that Microsoft produces, they basically do that pattern everywhere. Just look at the ASP.NET pipeline. A request comes in on the web server. Well, we don't really think about it anymore, but there's these HTTP handlers that look at it, and ultimately, out of all the things that you could do, oh, this is a request for an image. It needs to go over here. This is a request for a static file. It needs to go. Oh, no. This is a request that actually needs to be routed to Blazor. Like, all the frameworks are doing this type of thing, okay? So I encourage you to do it in your own code. And then the bus routes commands to whatever handler can handle a command. And semantics. A command can only be handled by one. That's just kind of how it goes. A query can only be handled by one. An event of something that already happened could be handled by an infinite number of handlers. It already happened. And I'm just kind of telling people, hey, who wants to know that this already happened, right? So commands, queries, and events. Let me get out of this Zoom. Okay, and this is what the code looks like. So refresh data. That's actually inside of a Blazor component, and you can see it's saying bus.send new auction by event ID query. Well, that's inside that auction application. It's a query, and then you can see several others. Bus.send auction entry query by ID. So instead of having a dependency on some data repository or data access class and then knowing the right method to call, instead you create an object. This is actually more object-oriented. You create an object that represents the concept, and then you send it to an abstraction, send it to the bus. All right? And then bus.notify, entry refreshed, that's an event. Something happened with the entry, something changed, we need to refresh it. Okay. Oh, one of the cross-cutting concerns that turns out is really easy. People always talk about logging and auditing and some security checks and things like that. Well, when you send all of your queries down a bus, turns out it's super easy to implement caching. And so look at the bottom where you can see the cache key. And it's not really the full example, but with caching, really simple pattern. Annotate the particular query class with a marker interface, iCacheable, and now the bus can have another class that kind of hangs on looking for these cacheable queries, intercepts them, looks to see if I have data that has been cached for that type of query, and then just send it back and bypass the data access operation anyway. So when you create these abstractions, tons of possibilities open up for you. Okay. All right. I'm not going to put the hammer down on that too much more, but anybody use Application Insights in Azure for telemetry? Or how about Datadog? How about Splunk? How about any others? All right. Use one. If you're not using one, use one of those APMs, Application Performance Management. It's kind of like a log aggregator plus more. Just by typically all of them, you point it to your application, you get tons of data. But Application Insights, if you're not using any of them, and you're in Azure, use Application Insights. Just by pointing it to your application, you're going to get tons of telemetry just because it knows .NET. You're going to get a ton of free stuff about Entity Framework. And then, if you've implemented the bus, it's super easy to, like this code does, basically say literally every command that's coming through, every query that's coming through, and every event that's coming through, look at the object, turn the properties of the object that's coming through the bus, turn it into a custom event App Insights class, throw it over to App Insights. What you get for free, and I'll show you later on, you get for free in App Insights a record of what every single user did in your entire application. Just by doing that. Because all of your screens in your application were already routing everything they were doing to the same spot. Okay? So you instrument one spot, problem solved. You don't have to go and instrument every little screen. Why? Because you actually created an abstraction between layers. So, my call to action, implement your abstraction right below the Blazor component layer. Don't let Blazor component code just call everywhere. Make that one pinch point. Okay. All right, this is another pattern here. One web service for WebAssembly that is not relevant for Blazor server-side. It's only relevant for Blazor WebAssembly. And here's the problem that I have. Let me just show you. All right, here's one application that has, come on, go away screen. All right, that has 2 web services. And, all right, this application isn't fully built out, but the gist of it is, hey, you have events at a church service, and you have a screen and a church bulletin. What's going on, right? And so the weather forecast, that's from the main template, right? Anybody who's created the Blazor template knows that this just comes with the WebAssembly template. Then you have your next, actually, Control F5. I'm going to show you the application. It's the template with one new screen. All right. So we have the fetch data controller. There we go. And another screen that just fetches data. And this one actually fetches it from an actual database. But you don't have to care about that. All you know is one new screen, one new reason to ask for some data, and that creates one new reason to have another web API controller. So think about what this pattern does. Now I have another screen. Oh, that needs some different data for some different reason. Okay, well now I have another web API controller. And then another screen. Got to get some more data, another web API controller. So you see this pattern is going to end up creating a ton of web API controllers. And then just to keep them straight, what do? We add Swagger. We start, well, I got to manage all these APIs, and I want to do it well, so let me add some stuff. And okay, so now we got this huge layer of web services. Why? Just because the default architecture of the framework that I chose kind of does it that way. Not for any benefit. And actually, these are not public APIs. I'm never going to share these APIs with some customer or some third party and say, hey, call these web services. No, these web services are only so that my WebAssembly application, which happens to run in the browser, can jump over the wire to the server. That's the only reason it's there. I actually don't want them. I don't want them, but I have to have them. Or do I? So let me go back to the reasons. All right. This is my pitch. If your HTTP API is public, yeah, use Swagger, tightly control the contracts, do your versioning, all the API management, firewall, security, all that stuff. But if your HTTP API is only for your own client and is intra-application rather than inter-application, it's within as opposed to between, use one web service, one web API controller, and then let that one web service handle any number of messages coming through, any number of reasons to jump over the wire, and just do it like JSON serialization. And I'm going to show you how, because anybody ever used Azure Service Bus or MSMQ or any of those durable message queues, RabbitMQ, right? They all do it. You don't have a different queue address for every message type. No, you typically start out until you scale. You got a queue, and guess what? I'm going to send every one of my messages down the queue, and there's a handler process that reads them in one at a time, and then, oh, these are different types. And then it routes it intelligently inside that process, right? But you have one transport. You have one conduit, okay? Same thing, same thing. I mean, what insanity would it be to do durable messaging with a different queue for every different message type? We would never do that, right? So I contend, why do it here? It's the same forces at play. Okay, so here's the here's the GitHub Blazor WASM single web API. I'll show you the high points to it. I have it right here. So Control F5, let me run this application just so that you can trust that it actually runs. All right, there's one reason to call back to the server. I went and asked for the name of the server, and just so I could write it to the screen, right? So what's the operating system, what's the version, and what's the machine name of the server, even though it's a WebAssembly application. Okay, go to the counter. I changed this so that I would do the counter, but then I would go and ask the server for its count, where the server adds 2 instead of adds 1, okay? And it returns me back the name of the server-side process that's running, okay? Which happens to be the project name of Visual Studio by default. All right, fetch data. We're going to load data from the server, and then we're going to click on one, and it's hot. We're going to update, and now it's been updated. So each of those clicks went round trip just to fabricate some additional reasons to go to the server. Okay, so what does this code look like? Well, let me go to the client. Let's just walk down there. We have the index page. Pretty simple. I say, okay, new server info with some basic stuff, but then I say bus.send new server info query. All right, new server info query. What is this object, new server info query? Jump into it. That's it. It's an iRemotable request, okay? And that's a marker interface that lets the bus instance that's running in the WebAssembly process to know, oh, I don't need to look for handlers here. This is a remotable request. I need to throw this over to the server. It'll be handled over there, and then it'll come back to me, okay? All right, so that's that one. Counter. Counter query, passing in the current count. This is basically a request. Hey, given this current count, here's my query. Will you give me something back? All right, again, it's a remotable request. And then we also ask for this server count, new count. Okay. Actually, the server count is, let me make sure I tell you this right. Yeah, the server count is the return type. So the iRequest of server count, that's the generic way of saying, okay, when handled, this is the type that I expect back, the server count. All right, so that's the count. Now fetch data. It has some more. Fetch data, when we load, we're going to say, oh, forecast query. All right, and then I get it back, and I set it to forecasts. And then if I select a weather forecast, I'm going to do the same thing. And then when I update, now I have a command because I'm actually changing some state. Okay, so I'm saying bus.send. What happens? Well, let's go into the bus. Let's get past the interface, actually go into the implementation. And remotable bus is where it is. Can y'all see this code, or is it too small? Okay, all right. If that's remotable request, then, let me just wrap this so you can see it. Oh, it turns out it's a syntax error if it's not on the same line. Look at that. Who would have known? Okay. Still not happy. All right. So that's all it does. It just throws. That's all you're missing. You're missing the exception. Okay. If it's a remotable request, then publish it to the gateway. And when it comes back, let's take the result and let's get the object body, casting it to the response type so that the typing is happy. All right, so there's this notion of a gateway. Well, what's the gateway doing? And by the way, the bus is just responsible for routing. The bus is supposed to be dumb. So it's not appropriate to put this kind of logic in the bus. But a gateway is responsible for kind of going off to something else. So the gateway actually jumps over the wire. All right, so we have publish. We create a new web service message. Haha, does anybody notice something interesting about this? Any of you who've used the Azure Service Bus SDK? I literally went to GitHub, I swiped the code, and I just changed a few letters. I literally copied their code for how they use a service bus message, how they have a body of the message inside a service bus message class with binary serialization, send it over the queue, and on the other side, they can deserialize the binary format into a C# type on another computer. And I did the same thing. Instead of using binary serialization, I used JSON serialization since we're going over HTTP. So I literally just used literally the same template that the Azure Service Bus team, and I applied it here. Okay? So that's the same pattern. So we have a web service message instead of an Azure Service Bus message class. And we send in our request, which could be a counter query, and send it in here inside the web service message. If I just control B into that, literally we're saying get body, which is, look at this, JSON serializer, whereas Azure Service Bus does binary serializer. Okay? All right, so passing the constructor, serializing for myself, it's all happy. Then send to, you know what? I should have renamed that because literally send to topic is the service bus one. All right, after this presentation, I got something to fix. So we're going to send it, instead of send to topic, it should have been send to server. And we are going to HTTP client post as JSON. And literally every message type comes through these 4 lines of code. And then we're going to return the deserialized web service message. Okay, so that's the round trip. So literally this is posting the JSON to the web service, which is where? Which is here. We have a single API controller for all, I'm going to count, 4 queries and 1 command that we have round tripping. Okay? 1 web API controller. And it is receiving 1 type, web service message. It's a known type. Web API knows what to do. And so it gets it back. And what we're going to send is we're going to send the get body object. We're going to send what that comes back as. So if I go into that, we get the type from the body, and we JSON serialize or deserialize it back into counter query or forecasts query or whatever it is. And now that I'm on the server, I'm doing a bus.send forecast query. Everything's happy. I jumped over the wire. I put the object back together from serialization. So now on the server side, it's none the wiser. Hold just a second. And it's sending it along. And we get the result of the operation. We get all the forecasts. And now I'm going to create a, let's see. And now I'm going to return the JSON of another web service message for the round trip back. Yes, sir.
So this breaks the REST principle, right? REST is more resource-based.
Oh yeah, this is absolutely not REST. This is basically, I don't want web services at all. I just want some way to hop over the wire. And if Microsoft gave me remoting, binary remoting, I'd be perfectly happy. I literally don't care how I jump back and forth from my client code to my server code. It's me. I just have a network in between. So yeah, I mean, REST is great because people can understand it. You have tons of people out there that are going to integrate with your web service, and they can figure it out, right? I mean, if .NET remoting was still a thing, I'd probably say, well, shoot, why don't we just use that, right? Okay, good question. All right, so any questions about this? I just walked through the code. You can get it on GitHub before we go on. Yes, sir?
So we are not using the Azure Service Bus here, right?
Correct. We're just calling a synchronous web service, but we're using the same pattern.
Is that pattern called a hub and spoke pattern?
No, I don't know that they named it, but we have a web service message which receives a domain object, one of my domain objects, which is a command or a query, and serializes it to JSON. Well, the service bus message in Azure Service Bus SDK, it serializes it to binary, keeps it inside, sends it down to a queue, and then when you pull it out with your handler, it deserializes from binary back to your object. Well, this just uses JSON, but it kind of does the same round trip.
Is it similar to Jimmy's mediator?
Okay, yes. Actually, let me show. under the covers, packages, under the covers, the mediator library is there. Okay? So, yeah, good question. I gloss over that. The bus itself, and this has a long history, by the way. In 2008 to 2009, there was a project. There was a project long time ago that this pattern was really fleshed out in a detailed way. And Jimmy was on that project. And anybody know Jimmy Bogard? Okay. And you said Jimmy. You mentioned Jimmy. Yeah. Okay. And that project sprouted Mediator. And then Jimmy's really great about keeping up with open source projects, and it's lived ever since. What I love the generic syntax that Mediator gives, and I love being able to use it in your own bus implementation so that you don't actually have to write any code to do all that routing, because Mediator does it fantastically. But as with any other third-party library, you don't want third-party APIs, and open source libraries are third-party. You don't want that API to go around all of your code in your application. Like, I think somebody told me this early in my career when I was like 19 years old. They said, no matter what you use, make a wrapper and use your wrapper, because something's going to change and you don't want to have to change it in a million places. Well, that's still true today. And so this does that. Mediator is doing that routing to the handler under the covers, but your bus implementation ensures that you have a class that can intercept any command, any query, any event that your application is sending through. All right, good question. All right, let's go back. All right, so let's talk about eventing in the user interface of a Blazor application. And this is regardless if it's Blazor WebAssembly or Blazor server-side, you're going to have multiple components that are alive in a particular screen. And one of the suggestions that I have is to factor every one of your screens into multiple components. I admit I'm not an expert in CSS, but one of the things that I picked up from kind of watching people who seem to be experts in CSS was the decomposition of every section of the screen and making the divs and spans so that every section of the screen was addressable from CSS and all that. Well, the same thought process applies here. If you have one component for the entirety of the screen, but you have a left pane, you have top navigation, you have bottom footer, you have this and that, then you're going to end up with spaghetti code because you have too many concerns represented in one component class. You have too many sections of the screen that have a different reason to change. That's another old adage with how to refactor code into different code files. If different methods or different parts of a class have a different reason to change, then you probably need to have two classes instead of just one. Same thing with a Blazor component. If you have two areas of the screen and they kind of think differently, figuratively, code likes to think. I like to personify code. Then break it up into different components. You're not gonna have performance problems. You don't need to worry about too many components alive at the same time. I think I've heard some people saying, oh, well, there's actually a limit. You don't want to do it too much. In practice, none of you are going to factor a Blazor component screen into that many components where you're actually going to even notice any type of performance difference. It's just not. So do it for yourself. Do it for readability. Do it so that you can maintain the application. All right. So now we have different parts of the application. Do we have different parts of the screen that are different Blazor components? And whether you do it a little or whether you do it a lot, even if you only have the left navigation and top header and body, well, right there you got three, right? Even if you only use the master page concept, you already have more than one. There needs to be communication with different components that are actually loaded on the same screen, so you're going to have to use eventing. And if any of you have used any of the JavaScript SPA frameworks or WinForms or WPF or any kind of desktop technology, heck, C++ or Delphi or anything that's stateful, you likely have used some type of eventing where the user hovers over some part of the screen or clicks some part of the screen, and some code on a different area of the screen just needs to know that happened. Even if it was, hey, I selected something from a tree view node. Our Windows programs used to have status bars at the bottom. And, depending on where you clicked, like little status messages would change. Well, you had to have eventing for that. All right, so here's an example. Here's an example of eventing. So you see the refresh timer at the top? This page, and this is from the auction application, this page declares the refresh timer. That's it, just sticks the refresh timer up there. Now we're inside the refresh timer component. No HTML, all right? This particular component has no visual elements whatsoever. It just has a behavioral responsibility, and that is to trigger a refresh timer triggered event by reading from the config file and say, oh, do I do this every 10 seconds? Do I do it, or do I do it at all, right? Based on the configuration. So all it does is say bus.notify event, okay? Now, other code, all it has to do, any other Blazor component, all they have to do is implement iListener of refresh timer triggered. It's an interface. Now you have to implement a method. So now we have a handle method that accepts refresh timer triggered, and I can run some code, refresh something, do whatever I want to, okay? All right, so this is universally useful across a whole number of scenarios. All right, so how do we put this in place? Actually, before I show you the code, you don't have to write the code yourself. There is a Blazor MVC NuGet package, and the bus pattern and eventing is in this open source package. Yes, I put it up there. I'm not a very good open source project maintainer, so if anybody has a hankering and they love to do that stuff, just let me know. But it's a very small library. If you don't like using the library, just steal the code and change it and use it as you see fit. All right? But the pattern is there, and the Blazor MVC is on GitHub as well. But it has the little bit of code so that the components can register with the bus on there, so that they're there for routing of the events. Okay. All right. Now let's talk about separation of things that you see from things that the code does. Anybody ever done ASP.NET MVC? All right. Web forms was a paradigm. WinForms, WPF, and Web Forms and Xamarin all have a paradigm where the UI code mixes something that you can see and something that the screen needs to do, and it mixes it in the same file. The ASP.NET MVC team came out with a framework that actually separated those two concepts into different code files, and that's universally a good idea. And so I'm kind of bummed that the Blazor team didn't give this kind of capability right out of the box. But it turns out it's not too hard just to implement your own pattern, okay? So that's another one of the pattern. The Blazor MVC library kind of gives you that pattern. It has a bus implementation, and it has cross UI eventing. All right, this is what the counter component looks like when broken up into a counter view and a counter controller. The counter view has HTML, right? Things that you can see. And it has some properties. Counter controller now owns the behavior, which includes the route, which includes the designation that, hey, /counter comes to me, and if I hit the button, what do? I increment the count and add by 1, or add by 2, or whatever the logic is, and then tell the view a new value, okay? The view, the model view controller pattern is really old. The view has the button, and when the button's clicked, all the view should do is basically route, just be a dumb router. And so the controller is actually setting a delegate to a method to the view, so the view doesn't even know that the controller exists. The view doesn't even know which controller is using it. The view has just a property that's of type action, and when the button is clicked, well, guess what? I was given this action, this delegate, I'm just going to invoke it, and it's to a controller, it's to a method on the controller. So the controller is in charge. The important part and the important difference between MVC and Model View Presenter or MVVM, if you heard of that, Model View View Model, is which object gets on the stack first. Okay? In Model View Presenter and Model View View Model, the view gets on the stack first and then is partially responsible for constructing or locating the controller or the presenter, whatever you call it, and then delegating. Model View Controller, the controller gets on the stack first, and then it's responsible for designating which view it wants to use. Or maybe not use a view at all if this controller's responsibilities don't include anything visible, which is a perfectly valid use case. Okay. I've already talked about solution structure, but I am going to talk about startup because I think this is important. Okay. Let me close the code. All right, notice how we have UI.API, UI.client, and UI.server in this particular application. Why is that? Let me just expand them real quick. And the API, see the dependencies, projects, just core. All right, our web services, so by default, when you do a WebAssembly project, you get UI.server and UI.client, right? And I don't like this, and I'll tell you why. UI.client's fine. UI.server has from a dependency perspective, the UI.server has a dependency on UI.client. UI.client doesn't have a dependency on server. So that's good because you're not typing code in your UI.client project with IntelliSense popping up saying, hey, why don't you use this class? Why don't you use this class? When it's really not appropriate. So that's all well and good. By default, the template puts web services in UI.server. Now, functionally, it works fine. But it also puts program.cs in UI.server. Program.cs is your startup class. And this is where Microsoft wants us to put literally everything that we have to wire up on the server side. If I'm using the Twilio SDK, put it in there. If I'm using the Azure Service Bus SDK, put it in there. If I'm using this library, put it in there. That, right? In order to wire up the services collection, I have to have a reference to it, right? So this program class, guess what? UI.server, just by the way it's designed, is a promiscuous project. It's going to visit with everybody, okay? And its list of references and dependencies is going to be a mile long. Now, functionally that works. Why would I care? Well, it's also the project that has my web services. So now I have some logic in web services that's going to end up growing unless you use my single web service pattern. And so now you have a project that literally references everything in the kitchen sink that you're also going to have some important code in there. All right, that breaks the single responsibility for that project. So I don't like that. And so what I advocate for WebAssembly is to take your web services and just factor them off into another project. And that's what I've done here with UI.API. Now, I just called it UI.API for naming convention, just to kind of, hey, it kind of goes with Blazor, just so that when people see it, they'll kind of group them together. But your web services, as long as they're in some project that kind of compiles down to a DLL that UI.server can reference and wire into services collection, .NET Framework's happy, okay? So that's what I advocate. And I actually attempted to take the startup responsibility away from UI.server just so that something else could start up and leave the template the way it is. But there are some assumptions with the tooling and Visual Studio and attaching the debugger and some other things that I actually don't understand, and it doesn't work. All right, I've actually tried for several days to get it to just start up a different way so I didn't have to have every single dependency being wired up inside that project. But there's too many dependencies, and I would be almost there. Oh, except now the debugger flat out doesn't work ever. Well, that's not okay, right? Things like that. So flip it the other way. If we leave the UI.server project with the single responsibility of just application startup and getting everything roped together, but no actual behavior, no actual logic of any kind, well, now that's one responsibility. Hey, get everything going. Pull everything together and get it going. Put our web services off to another project. Our WebAssembly, our Blazor components are off to another project, and that works well also. All right, any questions on that? All right. Had anybody heard that before? Or is this novel? All right. I like being told, you're crazy. Why would I ever do that? Okay. So this right here is now what my project dependency diagram looks like with my web servers and application startup factored out. And just from a dependency perspective, I have my data access, which is the interface to SQL Server, referencing core. I have my web services, also referencing core, and nothing references it. I have my WebAssembly code referencing core, nothing else. Unit tests, of course, those. And then UI.server, it's responsible for wiring everything together and starting it up, so it has to have a reference to all three. And then the integration tests, of course, have to know quite a few things just to do that thing. All right. Okay. Now let me come back to something that you've probably seen everywhere, but you might not have noticed it because everybody has to hide the truth. Has anybody gone to a React or Angular or Vue developed site and pulled it up, and it comes up really quick, and you're like, okay, let me start using this. Wait a minute. This is just grayscale bars animating back and forth, and I got to wait 10 seconds until some actual data shows up. Right? The mobile version of Facebook is notorious from that. Oh, let me show a feed, or let me show a series of things. Oh, there's 10 of them, and they're all little animating bars, but I'm not going to show you anything. It's just blocks of animation, right? Think about it. Think about it. This is a dog slow website, but they show you some little canned animations to try to trick you into not realizing that it's a slow website, okay? Well, why is that? It's because of the JavaScript framework that it's using, and that's just one of the natural things. It's not rendering the whole screen on the server and then just streaming it over to you. You got it loaded, and you click on something, and it immediately flicks to that new screen shape, but it's busy on the back end kind of going and getting the data and doing some processing. It doesn't have the data yet. The same thing happens with Blazor apps. Not because the technology is any different, and I would argue that Blazor and C# and the way it runs is set up for actual faster processing than the JavaScript equivalent, but I'll tell you why it's a similar problem. Yes, sir?
They are called progressive apps. You know, just displays only part of it and then slowly filling up with the data. It's called progressive apps.
You nailed it. You nailed it. So if you have a listing, I'm not talking about grids, but if you have a listing of 100 items on a screen, and this is a F12 Tools screenshot from the auction application where we're showing 100 animals for sale with all the bids and everything, but it would take upwards of 3, 4, 5, sometimes 6 seconds to load it, and we're like, why? And what came to find out is it's because of the browser DOM. All right. The query back to the database, super fast. Getting the data, super fast, super fast. Everything's super fast. All of our code, super fast. Now we're waiting on Edge or Chrome to just add the frames into the HTML DOM. We're just sitting there waiting. So F12, you can examine the frame loading right there in the F12 developer tools in both Chrome and Edge. And so I'd encourage you to do that. And so this actually exposed that this is where all the timing was going. So here's a trick that you can do in Blazor components. You have your collection that has the 100 items that you're going to bind to the HTML, right? So you set the items to display to the first 10, or however many you need to just show something interesting. In our case, below 10 was below the fold, and the user had to scroll to even see them. So 10, binding 10, what it did was it made a DOM change transaction 10 long instead of 100 long. Those DOM change operations kind of operate in transactions, where with 100, it wouldn't even show me the top 10 until all 100 had been bound, and then the HTML, the DOM changes all at once, okay, like a transaction. So what we do is we make a transaction of 10, and then this code state has changed. It basically tells Blazor, hey, interact with the browser and tell it to push this stuff into the DOM and change the HTML. And then it's like instantaneous. It instantaneously appears. And then if you're paying attention, about a second or two later, you can see the scroll bar on the right shrink because the page just got longer because the other 90 ended up getting bound, and now the HTML is there. All right. So if you ever get in a situation where you start to performance profile a screen, you're like, why is this taking so long? It shouldn't take this long. Here's a trick to get around that. Okay. SignalR is kind of one of the main topics here. Let's talk about broadcasted events. Let me set the stage for you. You've got 100 or 1,000 or an arbitrary number of connected Blazor users, and one person does something, and you want all the other people that are connected to your application to know. Okay? And think about it. In an auction, somebody does bid, everybody else needs to know that the price changed, right? Okay, so that's relevant. And it needs to be fast. Okay, it needs to be fast, near instantaneous. It doesn't actually need to be durable, because if something happens and somebody drops off and then they reload the page, well, they're just reloading the data, so they'll get the right answer. But while they're connected, while eyeballs are on the screen, and if you have a situation where one person does something and everybody needs to know right then and there to help the workflow, then you're going to need the concept of a broadcasted event. Now you can brute force Azure SignalR, and you can sling code and put Azure SignalR code all over the place and be messy about it. But here is a pattern for leveraging your bus abstraction, which by now you already have, and just adding on another marker interface. If there's an event object that goes through the bus and it has the marker interface of iBroadcastable, you make up these marker interfaces. You know, whatever you're implementing, just give it a name, iBroadcastable, and you put that on the marker interface that this event needs to be broadcast to everybody. Well, now there's another kind of a gateway class called Notification Broadcaster that listens on the bus, and every command query event, everything that goes through in Broadcastable is just going to be events by convention. But it's going to look for that marker interface, and if it is that, it's going to kick into gear, and the line of code notification.broadcast event, behind this code is the SignalR code, but you can see hubcontext.clients.group, group ID. If you're familiar with the API of SignalR, you can see that that's a SignalR code. And then hubcontext.clients.all, SignalR allows you to broadcast it to everybody or just segment it. But anyway, that's another pattern where if you find yourself in that situation, it's really easy to layer on if you have all of your Blazor components doing all their interaction through a single abstraction, which I've called a bus here in this presentation. Okay, let's talk about integration testing, unit testing and integration testing. There is a unit test library called BUnit, stands for Blazor Unit. if you go into the archives of the Azure DevOps podcast, I've interviewed the creator of BUnit and kind of talk about the architecture of that. But this is what BUnit code looks like. It's not complicated. There's a few special types called like I-rendered component of bid dialog. We have a, I don't show it here, but there's a BUnit context, that underscore CTX variable. We're going to render the component bid dialog, and of course this is for the auction application, so it's a little dialog that pops up for people to put in a bid. And we're going to render the component. Okay, so now we actually have the rendered component. We actually don't have to do the whole screen. This is unit testing, single component, right? Single component. And then similar to CSS identifiers, and if you've done Selenium testing, we're using a CSS, gosh, I'm blanking. CSS locator, what's the right term? CSS query, that's what it is. And we're finding, the hashtag bid button is the ID of property of an element bid button. All right, and then now that we found it, we're actually going to interact with the model that we've pushed to that component, which is the entry that is being sold in that auction, and we're going to change a property called block from sale. Interactively, that means none of the things that show the price, that make it available for bid, anything, those should be gone, because this is just to advertise the item. We're blocking it for sale. We're not selling it. There's no prices. So if we change that property to true, then we want to make sure that the bid dialog, that the bid button, second to the bottom, the bid button should not be there. Okay? So just simple stuff like that. If you have any visible logic in your components, here's a way to unit test those types of behaviors instead of leaving those types of behaviors to full system testing through the browser. Okay. Full system acceptance tests. I'm actually not going to go through here. I want to show you a live working sample. Now I've run the full build here, and so I'm going to go up, and we can see that they've already passed. But so you can run all these command line. But if I come in here, make sure this sucker is running. Control F5. While that's running, we have an acceptance test library that has one test fixture, just for demonstration purposes. For full system acceptance tests, you need to do something to separate the test scenarios. And it's different from unit test and integration tests, because even after you're done programming, somebody's going to come up with another scenario that mixes and matches different screens, and it's another test scenario, and we put it in the acceptance test suite. So whereas we might call, if we have a customer aggregate root object, we might have a unit test called customer tester, because all those test cases are testing methods of the customer, and once we're done testing, we're done. But full system acceptance tests, you're kind of never done. If somebody comes up with another scenario, guess what? You've got another test scenario. So you kind of organize the test differently. In this case, I just made a counter namespace and one test here. And to set it up, you have to do a few things called test host. By the way, if you're interested in that code, it's all on GitHub. Search for the Church Bulletin application on my GitHub, Jeffrey Palermo. And I have, let me make this go away. I have one test case. That's about how big it is. And yes, I've hard-coded this because this is a sample application for you. All right, we're going to tell Chrome or Edge, whatever driver we're using, to navigate to the address /counter. Then we have the CSS selector, click me button 2, which I've named. And then we basically say counter button, and we're going to wait until we find the element of the button. And by the way, this is one of the newer APIs of Selenium. It used to be that you throw in thread.sleep or some other things, but now we've got the web driver wait, where we can actually just sit there and it's like, okay, once this element pops up, now we can proceed with our test. Because if you don't, anybody ever done Selenium tests before? Okay, that's one of the things is you never know when the browser is going to be ready to proceed. And so this gives us a deterministic way of saying, okay, wait for this button, wait for this element. Okay, as soon as this element's there, I can proceed. Okay, so we're going to wait until it's there. And now we know the screen is painted. Then we're going to tell the test driver to take a screenshot. Screenshots are super important when doing full system testing with your Blazor applications or anything with a user interface. Then we're going to say, hey, let me find the element that matches this CSS selector, which is ugly, and I leave it as ugly to illustrate that you really do want something that is more deterministic, like using the ref attribute or a data dash attribute, whatever attribute you want to use, and give it a name. This stuff right here, not maintainable, okay? Now you can right-click F12 developer tools and you can get the XPath or the actual CSS selector, and it's going to give it to you in this format. That doesn't make sense. I've actually been doing CSS selectors for 17 years. This still doesn't make sense to me. You're not going to remember it, okay? So this is what not to do. Instead, you want to make up an attribute, stick it on there, and now you have a test interface. You have an attribute in your elements that is only going to change if you change your tests. Whereas this full CSS selector or XPath, well, guess what? If you refactor and just change some of your markup, you could accidentally break a whole bunch of your Selenium tests, okay? That's not fun. Okay, and so for each of the number of button presses, we're going to say counter button.click. Each time we're going to take a screenshot, and then we're going to make sure that the current count element text contains the final count that we expect it to be. And this is there because we have one test, but we've actually made 4 different test cases with the number of button presses and the expected final count. Now these numbers are the same because we're just adding +1. All right, so let's go ahead and just run. My application's running. Let's see if I can step back. Hands up. I'm not doing anything. All right. We're doing some robot testing here. Click on. Boom. Test case 1 is done. We're going to click twice on this one, right? Okay, dude. Now we're going to test. We're going to click 5 times on this one, right? 1, 2, 3, 4, 5. All right, and then the next test case, we're going to click 9 times. I mean, it's not complicated, but this is the pattern for testing your Blazor applications. It's kind of the same, very similar pattern to testing any number of web applications, but it works really well with Blazor WebAssembly and Blazor server side. Okay. All right, 9. And by the way, this type, because you're starting up Chrome and closing Chrome, these tests are really slow. Just by nature. Just this simple test case, you see how long it took to run? Well, now when you have hundreds of different things clicking around your application, it's going to be slow. So you're going to have to parallelize these tests just to get them all to run in a reasonable period of time. All right, so that is full system acceptance testing with Blazor. All right, I just showed you in real time. Okay, operations and monitoring. Anybody have anything in App Service right now in Azure? Azure App Service? Nobody? Okay. Well, what I was going to say, if everybody had raised their hand, is that 1 year ago, the V3 instances came out, and the prices were cut in half, and the horsepower was doubled. So if you haven't upgraded to V3, then make sure you do that, because you get more power for your money. I think that's probably going to happen again. And okay. As we go into operations, I want to stress that we want to instrument what your users do, not just what your application is doing. I'm going to blaze through here. I was interviewing Stefan Shakow, one of the architects on the Azure App Service team on the Azure DevOps podcast, and I got him to, I got him to tell me, hey, what should I be using for Blazor applications? And he said, well, for Blazor WebAssembly applications, it's just web services, so it literally doesn't matter. Whatever's always worked for any other web service, because it kind of sips at the resources, very small. For Blazor server-side applications, you have to think more of what type of server would you use to host a terminal server. where people are remoting in and have a terminal session. And so he said the smallest one for a Blazor server-side application would be a P1v3. Okay, that's so straight out of the horse's mouth. The guy who runs the thing, if you're in production, he says don't even go lower than P1v3, just because Blazor server-side needs that memory. And it's not so much CPU, it is memory. It's memory. Okay. So here's some application insights graphs. I want to talk about some graphs for Blazor server side because those are unique. The graphs for the server for Blazor WebAssembly are not unique because, again, all we're hosting on the server is web services. So all the knowledge from hosting any other types of web services, you kind of already learned what it takes to run a web service. And even if you are using my pattern of having every command, query, and event go to the same web API endpoint, still a web service, and it's still getting called a lot. Okay. All right, so these graphs are for Blazor server side. These are unique. There's a whole bunch of latency, right? Because of that, you don't want any wait time on the server. And so what we found was if you keep the server response time down below 10 milliseconds, then nobody could really tell any lag on those applications. Everything was basically instantaneous. Okay. Now again, you have to have a network with low latency, but as long as the server response time was below 10 milliseconds, it was pretty much instantaneous. Once you got above 10 milliseconds response time, then just from an experience standpoint, you could start to tell, oh, wait a minute, this was a slight delay. Okay. And then once you got to 100 milliseconds, you're cursing at the application and you're wondering what's broken. Okay. The average receiving response time kind of has a direct proportion to server response time, but it includes receiving the message back to the browser. And so what we found is as long as server response time was under 10 and receiving response time was under 100, everything was like super snappy, instantaneous. And once things started edging up above those thresholds, that's when people could start to say, oh, I clicked on the button and it wasn't quite as snappy as I was used to. All right. So those are some thresholds to kind of watch out for with Blazor server side. All right. So I talked about monitoring what people do, right? And I talked about instrumenting all the different commands and queries and events that go through the bus and just turning those objects into custom events for application insights and sending them all to application insights. Well, turns out when you do that, application insights basically runs itself, and you just can create your dashboard. So look at the dropdown. This is from the auction application that I showed you, and look at the things that I have checked. Register new buyer command. You could probably guess what that's from, right? A form where somebody wants to register as a buyer on the auction. Save buyer command, submit new add-on, submit new bid, right? Those are user actions. And so you get a dropdown, a selectable dropdown in your dashboard with all of your command types, your query types, and your event types for free, just because you sent everything over to application insights. And then you can create graphs by filtering, and you can plot it over time. So we can see over the summer, this was actually summer before last, when this was more being kind of developed and grown, you can see that the number of those types of operations was increasing from July over into the 2nd of August. But you could also see that there was some seasonality to it because most of the auctions happened to be Friday, Saturday, Sunday, Monday, but Wednesday, Thursday in the middle of the week, they just tended not to either schedule as many auctions or have as much traffic. So you can see the day over day and week over week seasonality, while overall from middle of July to August, there was increasing traffic or increasing operations. People were doing more things. On top of that, in application insights, if you're doing automated deployments and you have that hooked up to App Insights, you see those green check marks on the top? Those are deployments to production. So if you have one of these graphs and you're kind of tracking, and then it goes sideways, you're like, wait a minute, one of these graphs just started changing from normal. Oh, we deployed right then. I wonder if we caused it. It gives you a little bit of correlation where you can kind of look into that. You know, earlier I talked about tracking the number of open sessions you had with Blazor server side. Well, there is a concept in Blazor server side called open circuits, and you can run some counter code, and you can send a custom metric to Application Insights, and you can graph it, and that's what this is. And so I like to track open circuits, connected circuits, and disconnected circuits. Disconnected circuits are the number of users who've hibernated their phone in their pocket and are on that 3-minute timer. Okay, they're disconnected at the moment. They're still there, still using memory, but they're disconnected, and we're on that 3-minute timer. All right, and I also like to track for server side. I like to track average memory percentage. And like I said, connected circuits, disconnected circuits. Circuit handler is the name of the type to look for. If you want to override circuit handler and then register your class that inherits from it and put that in your services collection, that way when the Blazor code calls for a circuit handler, it'll get your class instead, and now you can do a little bit of code. And so this is just one example of, hey, on connection up, circuits count plus plus. Okay, that's, or whatever, however you want to do it. You know, you can write some arbitrary code in there. All right, my email address, I'll leave it there, jeffrey@clear-manager.com. The DevOps architecture poster, or if you don't get one of these, just send me an email and I'll get you a electronic copy of the book. We're on episode 18 of Programming with Palermo, so you can look at the video podcast there. All right, well, you guys have been great. Thank you very much.